Welcome, math models, to your trig function magic foldable. All we're going to be doing on this video, though, is the things on the outside. We're going to do the middle pages together in class. So I actually want you to start with, go to the inverse trig little flap, and go to the bottom. We're going to go ahead and put your calculator in degree mode. And if you are not the first class of the day, then your calculator might already be in degree mode, but check anyway. So you're going to go Home, Settings, Document Settings, and change angle to degree. It's probably in radian unless somebody has already changed it for you, and then make default and put OK. And then you can go back to whatever you're doing. So let's start with sine, cosine, and then we'll do tangent. So sine is basically the ratio of, so you've got an angle, it's always sine of an angle, and we're going to be doing them in degrees, not in radians. So if this were angle A right here, then you would have your opposite side. Opposite side is the one that is directly across from the angle. We'll talk about that together in class. You're going to be standing on a giant triangle and kind of acting it out. Super fun. Then you got your hypotenuse, which is across from the right angle. It's the longest side. This side is called the adjacent side, and we don't need that for sine. The sine of an angle just tells you what is the ratio of the opposite side to the hypotenuse. So it just gives you, for a given angle, it gives you the ratio of the opposite side to the hypotenuse. And you always want to make sure and pay attention that you are doing the correct, with reference to the correct angle. This down here shows you where to find your trig functions on the calculator. We'll get to that. Actually, right now, we're going to evaluate. So when it says evaluate, that just means calculate, which just means find the value of. So you're going to go to the trig function on the calculator, which is right here next to the 7. And then all your trig functions are here. We are only going to use these first 6 in this class. We do not do these in this class. So we are looking for sine. So choose sine. Put 67. And then the degree sign, especially if you hadn't changed the mode on your calculator like I suggested at the beginning, is going to be Control Book. And there's your degree sign. I'm going to go ahead and put it in this time just to show you. And you see the ratio of the opposite side to the hypotenuse of 67 degrees is 0.92. I'm going to round that. Let's round it to 3 decimal places, so it's going to be 0.92, and then the 5 makes the 0 go up to a 1. Now let me just show you. Since I had put my calculator in degree mode before, I get the same answer whether I put the degree sign or not. But you had to make sure that you did this process for that to work. So if you didn't do this and have it make default, then you're going to have to use your degree sign. So, all right, go ahead and calculate that one. Put the answer into Edpuzzle, and then come back right back and check. And you should have gotten 0.743. All right, so that's doing it with a calculator. Now, let's say we have a triangle already. We already know the side lengths. So to find the sine of angle S, here's angle S, I need the opposite side and the hypotenuse. Well, the hypotenuse is obviously 13 because it's across from the right angle, and it looks like it's the longest side. So this is the hypotenuse. Now the opposite side, so this is the adjacent side because it touches angle S. It's one of the rays of angle S. opposite side is going to be across from it, so it doesn't touch the angle at all. That's the opposite side. So the sine of angle S is 5 over 13. And if we could simplify that, we would, but we can't. Those are already in simplest terms. So that's it. That's the sine of angle S, 5 over 13. Okay, so let's do example 4 together, and then you're going to try example 5. So example 4, find sine of R. So here's angle R. Remember, I need the opposite over the hypotenuse. So the opposite side is going to be 9. It's the side opposite of the angle across from the triangle. Let me do it this way. So the 9, and then the hypotenuse is across from the right angle, and it does have to be the longest side. So this is hypotenuse, this is opposite, that must be adjacent, which I don't need. So 15. Now that I can simplify. I can divide both of these numbers by 3. So let me do that. And I get 3 over 5. So the sine of angle R is 3 over 5. Okay, go ahead and try number 5. You're finding the sine of angle A, so be sure you're looking with regard to angle A and just pretend angle B is not even there. And then come back and check. Okay, so you were looking for the sine of angle A. Here's angle A. Our hypotenuse is 17 because that is the longest side and it's across from the right angle. So 17 is the hypotenuse. Opposite of angle A, I have this side, which is 8. And then this was the adjacent side, which I don't need for sine. So the sine of angle A was 8 out of 17. Okay, let's try cosine. So cosine's pretty similar, except if you've got your angle, you are now making the ratio of the adjacent side to the hypotenuse. So the adjacent means next to. So it's the side that's next to the angle. And as you can see, if this is angle A right here, the adjacent side is right there. It's kind of one of the sides that forms the angle. So that's what you're going to be looking for. The adjacent side over the hypotenuse. And honestly, the hardest part about sine, cosine, and tangent is just figuring out which side is adjacent and which side is opposite. It just confuses a lot of people. So we're going to be working on that together. All right, so we got some evaluate problems again. So let's do the first one together and you'll do the second one. So again, find your trig button. Choose cosine this time. And either make doubly sure that your calculator is still in degree mode or go ahead and put the degree sign in. Otherwise, you will not get the correct answer. And my cosine is 0.391. Okay, so you go ahead and try the next one. Okay, so you should have gotten cosine of 48 degrees is 0.669. So let's try some others. So example 3, find cosine of S. So this is kind of like these problems here. We have a triangle. We have the side lengths that we need. We just have to write the ratio. So I'm going to be writing the adjacent side over the hypotenuse. So first figure out if this is angle S, this must be the hypotenuse because it's across from the right angle. And this must be the adjacent side. So I'm just going to say cosine of S equals adjacent, which is 12 out of 13. And that was all there was to it. So why don't you try this one? Remember, we're starting on angle B, so start here. then you need the hypotenuse and the adjacent side. Actually, let's find those together, and then you can write the ratio. So hypotenuse is the longest. It's across from the right angle, so this must be the hypotenuse. The adjacent side is one of the ones that makes up the angle, so this must be it. And the opposite side is over here, which we don't need. So that gives me cosine of b equals what? What do you think? And hopefully you said cosine of b would be 24 over 25, adjacent over hypotenuse. Okay, so now we're going to try a little bit of a harder type of problem. A little bit harder, not too much harder. Find the length of x. So I've got this triangle, I've got an angle, and I've got, looks like the hypotenuse and the side adjacent to angle A. So when I see adjacent hypotenuse, I need to think cosine. So I know I'm going to have cosine. Because I've got adjacent over hypotenuse. So when I'm finding a missing side, though, what I want to do is take the cosine of the angle, and notice it does give me the angle. So cosine of 50 degrees. And I know that's the adjacent over the hypotenuse. So I'm just going to fill in what I know. I know I have the cosine of 50. In fact, you know what? Let me finish this out here, because that bothers me, just having cosine hanging there. The adjacent side is the unknown, it's x, and the hypotenuse is 17. So I just need to figure out what x is. Now, you could end solve this if you really wanted to, I guess, but all you really need to do is cancel out this 17, and to do that, you just multiply by 17 on both sides, and that will cause this to cancel. And then you will have your missing side length. So let's do that. Let's do 17 times cosine of 50 degrees. Not that you can see that. There. So it looks like it's about 10.9274. So x equals 10.9274 is our missing side length. Cool. All right, turn it over. Let's look at tangent. Tangent of angle A. So here's our angle A. Tangent gives us the ratio between the opposite side and the adjacent side. So if you're looking at your angle, this is clearly the hypotenuse because it's across from the right angle and it's the longest. Opposite side is going to be here, and adjacent side is one of the sides that makes the angle, so right here. And we're going to evaluate just exactly like we did the other two. Just go to your calculator, press Trig, choose tangent this time, 67 degrees, and I get 2.356. So that's the ratio between these two side lengths. So that means that opposite side is way longer than that adjacent side. Doesn't look like it in the picture because the picture is not to scale. And so you go ahead and try that one. And hopefully you got 1.111, just like that. Okay, good. So now we got some just like these that we did with the fractions. You got the angles, or the triangle sides already. So now you just write the appropriate ratio. So we got tangent of C. So we want the opposite side over the adjacent side. Here's angle C. So go ahead and identify your sides. Clearly this is the hypotenuse. It's across from the right angle, it's the longest. Then angle C is made up of these two sides, so this must be the adjacent. And then this is the opposite because it's across from the angle. So I need to take the opposite side over the adjacent. So the opposite is 36 and the adjacent is 77. And then simplify that if you can, but it doesn't look like we can. So, yay! So you go ahead and try example 4. You are looking for the tangent of A, so make sure you do everything with respect to A. Go ahead and identify your sides first. So this is what it should look like once you've identified your sides. Your hypotenuse is 53. It's across from the right angle. Then 45 is across from angle A, so it's the opposite. And then 28 is one of the sides that makes up angle A, so it's the adjacent. So then go ahead and write the tangent. Remember, you're doing opposite over adjacent. And so you should have gotten tangent of A is 45 over 28. And again, if you could have simplified that, then you would want to go ahead and do that. All right, last example, you're going to kind of do part of it yourself, and we're going to do part of it together. So let's see. We want this length of side x. So here's side x. Now this problem's a little different because I've given you all the angles here. You could use this angle or you could use this angle. Let me just show you the difference there, and then you can decide which one you want to solve. So if I use angle, the 35-degree angle, then I'm going to have the opposite side over the adjacent side. Whereas if I use this one, let me erase all that. If I use the 55-degree angle, that would give me opposite over adjacent. So I could solve it either way. Now, both of these will give you the right answer. So both are correct. So it's not like you're going to be wrong if you choose one versus the other. However, I will tell you it's a little bit easier to solve if your x is on top and you have a number on the bottom, because then you're going to do exactly like we did on the cosine problem, where you just multiply by the denominator on both sides and that's it. This way, it's not that it's harder, but there's a little bit of extra steps and it's maybe not quite as intuitive. So you could really solve it either way. I would recommend, though, that if you don't remember a lot from Algebra 1, that you go ahead and do it this way. And you'll just do the same thing as you did here. Just multiply by the denominator on both sides. Okay, so go ahead and solve it your preferred way, and then come check your work. Okay, so I realized I put on this side, I put the degree sign outside the parentheses instead of inside, which is it's a really weird thing to do. I don't know why I did that. So fix that, please, if you copied me. Anyway, regardless of which way you solved it, you should have gotten approximately 18.566. If you solved it this way, as I recommended, then you would just multiply both sides by 13, and you get your answer. And if you solved it this other way, then what I did was put the tangent over 1 so that they would look like a fraction. And a lot of you are comfortable cross-multiplying, so you would just do 1 times 13, and divide that by tangent of 35 degrees, and you still get the same result, either way. Alrighty then, well that's it for these notes. We're going to do inverse trig in class together another day. So make sure this goes in your journal. I would recommend creating a little pocket for it so that you can keep it and you have it for the final exam. And thank you for watching.